Hi, I'm Kevin Keller, the pragmatic statistician. In this episode of Street Stats, we're going to talk about DOE, design of experiments, and experiments with small power. In a previous episode, I gave a simple example of a 2x2 experiment on a farm. What I didn't mention was that the experiment was designed with low power. Power? What's power? Not the simplest concept in statistics. Let's hope this helps. You're running an experiment because you want to see if making a process change makes a difference. Now, how big is that difference? Tiny amount? A medium amount? A lot? The answer always is, what minimum difference does the business now start to care? That's your call. A similar discussion is in another episode of Street Stats on estimating sample size when you don't have data. Now, that episode's either out there or in a future episode. We'll find out. What makes matters worse is that you are testing for that difference in the midst of noise. It truly is signal to noise. How big is the signal, the change, and how big of a signal do you care about? Now, here's another problem that you're going to have. DOEs are delicate, they are fragile. Anything that could go wrong might. And if it does, it destroys the results. So, one of the strategies to combat all of this is to run what we call replicates. To keep it simple, you have 4 runs in an experiment. You run all 4 runs. That's one replicate. You turn around and run those same 4 sets of runs again. That's a second replicate. And if you were to do all 4 again, that would be a third. Now, here's the deal. Businesses do not have the patience to run replicates. Experiments are often costly. I can hear that plant manager right now yelling, "What do you mean that statistical weenie is telling us that we have to run all of these tests again? We don't have time for that. Run it all right now, and I want results quickly. What do we need to do? We don't have time for replicates." So it's important that you know what power means and how it plays in to developing a strategy for dealing with that plant manager and getting the job done. So let's define power for the difference that you care about or the business cares about. If, big, bold font, if that difference truly exists, what is the probability that when you run that one replicate, you're going to see that difference? Obviously, we would love high power. Power is directly tied to the number of replicates in design experiments. So let's see how this all works. We're going to go to Engine Room and we are going to go and we're going to create a brand new design of experiment and we're going to go ahead and design it. I'm going to add a third factor just so we've got something a little more complex. And that's probably something that we might do in our real world. And so immediately, without doing anything on this worksheet, it tells me if I run one replicate, I have a power of 17%. But if I run 2, I have a power of 93%. That's pretty big difference, right? But that's based upon the inputs that we put up here. So I'm going to share with you that when I run design of experiments, I'm typically looking for signals and I'm willing to be wrong at the beginning about those signals. So I might run an alpha level of zero point 0.1 rather than an alpha level of 0.05. That's my experience. And so now you can see that the power went from 17% up to 34%. Hey, that's great. But what does 34% mean? It means if there really is a difference in turning those knobs with those different factors and getting a different result, I have a 1 in 3 shot of seeing it. So my odds aren't great. Typically, I like power is 60% and above when I'm running experiments, but that's not always possible. So, what are my other options? Well, right now, the default is set up to measure two standard deviations away from our current setting. So you might say, that's huge, Kevin. That would be just that's huge. So let's just make it one standard deviation away. What does that look like? And all of a sudden we can see our power drops to 18%. The smaller the difference, the smaller the power. So you go, gosh, that looks ugly. Now, you can actually put in real units, or you can use the ratio of standard deviation to, uh, or the difference to the standard deviation. Well, we could say, what if we're looking for a huge, huge, huge change? Three standard deviations, we're almost at 50% power, 49%. So, um, a lot of software has packages like this that you can go through these calculations, but recognize when you run a single replicate, power is always going to be low, no matter how you game these numbers. All right? So you are now convinced that you always need to run at least two replicates to get a decent chance at seeing a difference. But you have a plant manager who wants it all done in a single replicate. You're a little stuck. You can't really change the standard deviation. The standard deviation is the standard deviation. And you really can't change what the business cares about. I mean, you can change the numbers, but at the end of the day, the business cares about what it cares about. Those are kind of frozen in place. You don't want to drop that alpha beyond zero point 0.1 or 90%. So as you saw, it helps a little, but not enough. Is all lost? And the answer is no. Now, here's my strategy. What I call running a low power test is a test of catastrophe. Now, you're not going to find that in any textbook. If you Google it, it is not out there. That's just me. That's what I tell my clients. I never back away from running a test of catastrophe. I will still run it because there are three possible outcomes, and two out of the three aren't bad. You actually get statistically significant results. Hooray! So now you can declare victory. Power no longer matters. You got what you were looking for. Now, run a confirming experiment before you go change your process, but hooray! It could also be that the actual difference was a little larger than what you expected it to be. Here's another good scenario. The p-values are really, really, really large. 0.8, 0.9, close to 1. All of the different subgroup means are about the same. There's very little variation from one experimental run to the next experimental run. Now, here's where your business sense kicks in. If you did the experiment correctly, then the next time, will you really expect different results? My gut says if the means are relatively close of each experimental run, then likely running it a second time is not going to get me any new information. So stop. Tell your plant manager, we're done with this experiment. Now, sadly, nothing was significant. And now you need to go off and find other variables that might make a difference. But here's number three. If you don't get a statistically significant result or signal, but things are starting to show a potential signal. Main effects might be significant if we had run some more. You need to go back to that well and see if you can get more resources. Now, if your plant manager goes, nope, no more resources, then I would look at those results and figure out, would it be catastrophic if we changed? Hence the name, test a catastrophe. So let's walk through a couple of examples. You want to reduce costs. You're testing a new vendor with a cheaper supply. For the parameter you care about, higher is better. Higher is better. When you look at the main effect, you see the average of that vendor is a little lower, but it's not statistically significant with a single replicate. If it is actually worse and you didn't quite see it, then it would be catastrophic to change. Costs may go down, but so could quality. Same example. Bringing in a vendor to reduce costs, higher's better, but this time the main effect average for that vendor is actually higher than the average, overall average. You didn't get any signal that catastrophe is looming. So you might be inclined to go ahead and make that change. Might not actually be better, but that wasn't the goal of the experiment. The goal of the experiment was, is it going to be worse? So you didn't see a signal that it could be worse. You didn't get any inclination. We'll watch it for a while, but as long as things don't go south, it was probably a good call. Let's turn that all into a third example. This time you're evaluating a vendor who's actually more expensive. The thought is, the more we spend, the higher the quality. And the goal is to actually improve quality. Unless you get a statistically significant signal for the difference you desire, you could potentially be building in costs into your system that doesn't add any value to the customer and costs you money. You need to get a statistically significant signal before making that decision. Add a replicate. So there's not a clear-cut answer of what to do. Lots of plans based upon the business question. But hopefully you have learned that all is not lost when your plant manager ties your hands with one replicate and thus low power. My tagline definitely resonates today. Careful out there. The streets are messy and so is data. But remember, there's always a way.